there is a different way to explain what generative AI models actually do. It does not begin with algorithms. It begins with a simple but radical distinction: the difference between the world and the representation of the world. We often treat these as the same. We assume language describes reality, but language primarily preserves traces of how humans construct the representation of reality. Every sentence is an indirect measurement of a cognitive process, a compressed record of inference, decision, uncertainty, and explanation. Human language does not contain the world. It contains the history of interactions between minds and the world. In this sense, language is an archive of compressed cognitive states. And when we examine large linguistic corpora, we are not only observing facts, we are observing patterns of reasoning, priors, systematic errors, metaphors, and implicit causal models. For instance, in medicine, this is especially clear. Clinical language is a record of diagnostic reasoning. It is thought made observable. From this perspective, a key insight emerges. If language is a projection of world representation, then training a large language models means estimating the inverse function, not from the world to language, but from language to an implicit model of the world. The transformer can be understood as a form of reverse engineering of the mind that speaks about reality. The model learns the distribution of texts, but those texts are produced by minds trying to make the world intelligible. Embedded within the distribution are the constraints on how humans represent reality. Training does not recover the world itself. It recovers the inferential structure humans use to understand it. And this places generative AI within a well-known scientific framework, the inverse problems. Across physics, imaging, and biology, observing outputs allows us to infer generative systems. Tomography works this way. Clinical diagnosis works this way. Physicians do not see directly the disease, they infer the model that produces symptoms. And language models operate similarly. They observe linguistic signals and infer cognitive structure. In this sense, they function as imaging systems of human cognition. When we train models on massive text corpora, we're not teaching vocabulary. We are exposing traces of human thinking. And by learning regularities in those traces, the system reconstructs implicitly the inferential maps that generated them. This is not just reverse engineering of the world. This is reverse engineering of the mind attempting to explain the world. Technically, this manifests in several emerging phenomena, like implicit world models, approximation of causal structure, and reasoning as statistical simulation. To predict language effectively, the system must capture constraints embedded in human discourse. Not because it directly knows reality, but because it models how humans talk about it. When these structures become sufficiently coherent, simulation becomes operational. This is where the perception of operational understanding emerges. This process is not a single inversion. It is a distributed inference at scale. Rather than reconstructing one representation of the world, the model forms a space of representations compatible with human language, a latent space of possible worlds. A useful analogy comes from medicine. A patient speaks, symptoms emerge. The physician infers the generative process producing those symptoms. Likewise, language models infer mental structure from linguistic evidence. Predicting language well increasingly means simulating the cognition that generates it. In this view, understanding is not a binary state, but a gradient, the growing capacity to simulate generative processes. This interpretation reflects a broader convergence across disciplines: concept learning as inverse inference, predictive generative models, world model research, and representation learning. Learning in each case involves reconstructing the process that produces data. Now, a concise formulation follows. Language is the compressed trace of how humans model the world. The transformer learns to predict these traces and, in doing so, reconstructs the cognitive structures that generate them. And generative AI can therefore be interpreted as a reverse engineering of the human representation of reality. The philosophical implication is striking. If language contains maps of the mind, then training on language approaches simulation of mind. Not because machines experience the world, but because they learn the rules humans use to make it intelligible. The deeper strangeness is this: billions and billions of sentences form a collective tomography of human cognition, and the transformer is an instrument attempting to reconstruct the tomography, voxel by voxel, within latent space.